This star is in its Tauri phase. It's surrounded by a giant donut-shaped disk of dust and gas circles. Most of the material in the disk falls back onto the star, but some dust particles crash into one another. If the collision is relatively gentle, they clump into much larger objects. At first, these objects are no larger than the width of a strand of human hair. With time, dust clumps turn into pebbles. Pebbles become large rocks. The gas helps these rocks stick together, and while some of the bigger objects break apart, most of them turn into the building blocks of future planets, planetesimals. While orbiting the star, the planetesimals clear all the material away from their path. All that is left behind is just some fine dust. Billions of years later, the disk surrounding the star completely transforms. It's now colder and farther away from the heat of its parent star. The water it contains can finally freeze, and tiny particles of ice are now traveling around the star along with the dust. With time, they form snowballs that later turn into giant planetary cores. And since these regions of space are colder, gas molecules there slow down and get drawn into this core. Astronomers believe that's how gas giants like Jupiter, Saturn, Uranus, or Neptune are formed. Interestingly, Jupiter and Saturn were the first planets to form in the solar system. It took them a mere 10 million years or so. Closer to the star, other planets begin to appear. Those are rocky planets like Mercury, Venus, Earth, and Mars. Such space bodies can take tens of millions of years to form after their star is born. After planets start orbiting their star, they are referred to as a planetary system. This system can consist of one or several planets and include natural satellites, asteroids, dwarf planets, meteoroids, and comets. The Sun and the 8 planets orbiting it are known as the Solar System. The closest planet to the Sun is Mercury. The place looks eerily similar to the Moon, Earth's natural satellite. But from up close, it becomes clear that it's just an illusion. Mercury is one of the 4 rocky planets of the Solar System. It has a solid surface. All over the place there are craters created by space rocks. Mercury is the smallest of all the 4 inner planets. It's just 3,000 miles at the equator. If you decided to see the entire Mercury, it would take you about 2.5 days to drive all the way around the planet. That is, if you were driving your car at a speed of 50 miles per hour without stopping. But driving there wouldn't be a simple task. The planet's surface is littered with gigantic hills with steep slopes. Some of them reach a height of 2 miles. Mercury doesn't have an atmosphere, and the temperatures on the planet are extreme. 800 degrees Fahrenheit during the day and minus 290 degrees at night. It's also the second densest planet in the solar system, topped only by Earth. Mercury has a massive metallic core. It takes up almost 85% of the planet's volume. The core alone contains more iron than any other planet of the solar system. Not so long ago, astronomers discovered that Mercury might have not only the outer core, which consists of liquid metal, but also a solid inner core. The planet's outer shell is composed of a rocky mantle and solid crust, which is just 300 to 400 miles thick. Instead of an atmosphere, Mercury has a thin exosphere. It's made up of mostly oxygen, sodium, hydrogen, helium, and potassium. But the planet is too close to the Sun. That's why the solar wind and striking meteoroids keep sweeping away the atoms of this exosphere. Now, Venus is very different from the bluish planet you might have seen in pictures. It's surrounded by a super-dense atmosphere made up of carbon dioxide. If you decided to land on the planet's surface, you'd have an opportunity to observe thick clouds of sulfuric acid pass by. By the way, if you need a drink on Venus, be sure to only drink H2O. If you drink H2O too, well, that'll be your last drink. The planet's surface is actually reddish-brown. Venus is a dry and hot place, with a pressure 90 times greater than that on Earth. Flat, smooth plains cover 2/3 of the planet's surface. But there are also large mountains. Those are volcanoes. Most of them are extinct, but some might still be active. Venus has 2 vast highland areas the size of South America and Australia, and several expansive lowlands. There are also long, winding canals. There, old lava flows, and some of them reach 3,000 miles in length. The planet's dense atmosphere creates a greenhouse effect, similar to that on Earth. It traps heat, and temperatures on Venus rise up to 880 degrees Fahrenheit. That's hot enough to melt lead. The pressure on the planet's surface is the same as at a depth of 3,000 feet underwater on Earth, crushing. The planet's metallic iron core is 2,400 miles wide. That's almost as much as the distance from New York to Los Angeles. The next layer is a molten rocky mantle that's 1,200 miles thick. Venus's insides are covered with a crust. It consists mostly of basalt and is 6 to 12 miles wide. The planet's thick atmosphere is nightmarish. It's 96% of carbon dioxide with 3% of nitrogen and thick clouds of sulfuric acid. Earth is the third planet from the Sun. From space, it looks like a blue marble with areas of green, yellow, brown, and white swirls. All that blue area is water. It covers 71% of our planet's surface. Even from up there, you'd spot the Great Barrier Reef near the shores of Australia. It stretches for 1,600 miles. That's more than the distance from Boston to Miami. From space, you could also see all the 277 miles of the Grand Canyon at once. Earth is the densest planet in the solar system. At its center, there's a core that takes up 15% of the planet's volume. The core consists of two parts, the outer and inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles. That's 20% of the entire Earth's radius, or 70% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also contains iron and nickel, but it's not under enough pressure to be solid. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the Sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. The mantle surrounds the outer core. This layer is about 1,800 miles thick and makes nearly 84% of the entire Earth's volume. It consists of silicate rocks rich in iron and magnesium. The crust is a relatively thin layer that takes up only 1% of the Earth's volume. Along with the upper part of the mantle, it's broken into tectonic plates. They move as fast as your fingernails grow and let heat escape from the Earth's interior. The crust is mostly made up of oxygen, silicon, aluminum, iron, and other minerals. The fourth planet from the Sun is Mars. It's the last of the inner planets. They're also called terrestrial, since they're made up of rocks and metals. This place is freezing cold. The temperatures here drop down to minus 80 degrees Fahrenheit. Even from afar, the planet looks reddish. It's mostly because the ground there is covered with rusty-colored dust. The same fine dust is floating in the air. Mars is full of colors: golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places it's 7 feet thick. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. The tallest planetary mountain in the solar system, Olympus Mons, is on Mars. It's 2.5 times higher than Mount Everest and about the size of Arizona if you stretched a tape measure across it. Martian atmosphere is much thinner than Earth's and contains 95% carbon dioxide and a mere 1% of oxygen. Dust storms sometimes cover the entire planet, and the largest ones can even be seen from Earth. Mars has a core that's made mostly of iron, nickel, and sulfur. It's between 900 and 1,200 miles wide. The core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. The mantle surrounding the core is composed of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1,100 miles thick. The thin planet's crust consists of volcanic basalt rock. Astronomers think it isn't broken into tectonic plates and remains in one piece. The crust is covered with fine reddish dust that looks like talcum powder. Moving on, Jupiter is the largest planet in the solar system. It's more than 89,000 miles wide at the equator. Jupiter is so huge it could fit 1,300 Earths inside it. It's also terrifyingly hot, about 43,000 degrees at the core. It's impossible to land on the planet. Jupiter is a gas giant with an atmosphere made up of hydrogen and helium gas. It's hidden away by a layer of thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. One of the most unusual phenomena on Jupiter is the Great Red Spot. That's an enormous spinning storm the size of our home planet. It's been raging for the last 360 years. The hurricane's color varies from pale salmon and white to dark brick red. It's extremely windy on Jupiter, with wind speeds ranging from 200 to 400 miles per hour. Like I said, Jupiter is a gas giant. If the planet was 80 times as massive as it is now, it would have a chance to turn into a tiny red dwarf star. It's still unclear whether the planet's core is a molten ball of liquid or a solid rock 14 to 18 times the mass of Earth. There's even some evidence that the gas giant's core might be melting right at this moment. Whatever the truth is, the temperatures at the center of Jupiter reach 63,000 degrees. Around 90% of the planet's atmosphere is hydrogen. The remaining 10% is made up of helium with tiny traces of other gases. Under immense atmospheric pressure, hydrogen and helium gases turn into a dense fluid. Closer to the core, this liquid becomes a mixture of metallic hydrogen and helium. Since there's no solid ground on the planet, astronomers define the planet's surface as the point where the atmospheric pressure equals that on Earth. You wouldn't be able to stand on that surface, though. It's just another layer of gases. But the gravitational pull there is more than 2.5 times more powerful than on our planet. Now, like Jupiter, Saturn doesn't have any solid surface. This planet's made up of mostly hydrogen and helium. If you visited it, you would notice that the temperature and density on Saturn change the deeper you go. If you wanted to step on Saturn's surface, you just fall into the planet. Its gravity is similar to that on Earth, and the density at the surface is very low. That's why you'd free fall until the ever-increasing pressure crushed you. Now from above, it looks as if the gas giant does have a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. The visible outer layer is ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Saturn is an extremely windy place. Wind speeds here reach 1,100 miles per hour at the equator. For comparison, the fastest wind speeds on Earth don't exceed 250 miles per hour. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. The atmosphere of Saturn isn't really different from its surface, but the deeper you go, the higher the pressure is. At some point, it makes hydrogen turn into a liquid. Further to the center of the planet, this liquefied gas turns into metallic hydrogen. Like Jupiter, Saturn might have a rocky core with hydrogen and helium surrounding it. On the other hand, even if it's made up of rocky material, the core can still be liquid. One of the most recognizable features of Saturn is its awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. Saturn also has 53 confirmed and named moons. Another 29 moons are still awaiting confirmation of discovery and official names. Titan, an icy world bigger than our moon and even Mercury, is the largest of Saturn's moons. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. If you found a pool of water huge enough to fit the ringed planet, it would float on the surface. And still, because of its large volume, the planet is 95 times more massive than Earth. Out further, a blue-green ball of ice and gas 1.7 billion miles away from the Sun is Uranus. This ice giant has such a beautiful hue thanks to the light from the Sun. It gets reflected off the planet's surface. The planet isn't solid. If a small asteroid collided with Uranus, it would simply fly through the upper atmosphere and sink into the icy liquid center. Now, Uranus orbits the Sun on its side. It's the only planet with its axis pointing almost directly at our star. It might be because of a collision with a large space body soon after the formation of the planet. In summer, extreme storms shake the planet. Such hurricanes only occur when Uranus is heated to its most. A hurricane can sometimes spread for over 6,000 miles. That's almost the distance between Japan and the US. The planet has two sets of rings. The inner system consists of 9 narrow dark rings, and the outer rings are bright, one blue and one red. At the very center of Uranus, there's a rocky core. It's small, just half of Earth's mass. Compared to other planets, Uranus's core is rather cool, a mere 9,000 degrees. An ice mantle surrounds the solid core. It takes about 80% of the planet's volume. It's not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia ice, and methane. Sometimes it gets referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium. The planet looks blue-green because of methane gas that absorbs the red light. Now, the farthest planet from the Sun, Neptune, is only 4 times the size of Earth, but 17 times as heavy. The blue surface you see in pictures is actually a layer of swirling gas and permanent clouds. The planet's mantle, which is made up of water, ammonia, and methane ices, is the closest thing Neptune has to a surface. And still, this surface isn't solid. If you made a decision to get down to the very core of the planet, you'd feel great temperature changes. It would vary from minus 340 degrees at the surface to more than 12,000 degrees at the core. Such mind-boggling temperature differences create powerful storms whose speeds reach 1,200 miles per hour. No wonder Neptune is considered the windiest planet in the solar system. Like Uranus, Neptune is an ice giant. The planet's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times greater than that of Earth. Astronomers also believe that at a depth of 6,200 miles, there might be a layer where it rains diamond crystals. The planet's core is surrounded by a large mantle. It's a superheated region of liquid with temperatures as high as 3,000 to 8,500 degrees Fahrenheit. The mantle is rich in methane, ammonia, and water, and equals up to 15 of Earth's masses. Neptune's atmosphere forms 5 to 10% of the planet's mass. It stretches 20% of the way down to Neptune's core. The atmosphere consists of 80% hydrogen, 19% helium, and a bit of methane gas. The methane gas is what gives the planet its bluish hue. But what do planets look like outside our solar system? Are they the same as our rocky worlds and gas giants? Well, some of them are pretty bizarre. We're now 40 light-years away from Earth, near an exoplanet called GJ 1214b. By the way, an exoplanet is any planet outside the solar system. It's about 3 times the size of our planet, but its mass is 8 times that of Earth. Once every 38 Earth hours, GJ 1214b orbits a red dwarf star. The temperatures on the surface of the planet are literally toasty, around 400 degrees Fahrenheit. But that's not the only thing that makes this planet so unusual. After observing this distant world through the Hubble Space Telescope, astronomers have calculated that GJ 1214b is a giant water world. It's encapsulated by a steamy and dense atmosphere. There's no other planet like that known to people. Because of the high pressure and high temperatures on the surface of the planet, such exotic materials as superfluid water and hot ice might have formed there. Meanwhile, this bright blue exoplanet is located 62 light-years away from Earth. It looks peaceful and slightly familiar. It's a bit larger than Jupiter, and its bluish color might remind you of our home planet. But this pretty appearance hides the planet's terrifying nature. Its beautiful hue comes from silicate atoms and particles that make up the planet's atmosphere. At the same time, the wind speeds there can reach a terrifying 5,400 miles per hour. That's 7 times the speed of sound. Temperatures on the planet are also extreme, over 1,600 degrees. But even this is not the worst. It rains glass, sideways, in this scorching hot world. If such a storm happened at the equator on Earth, it would only need around 5 hours to travel around the planet and destroy everything in its path. Several years ago, astronomers discovered a planet as large as Neptune, and it orbits a star that's no bigger than Earth. That's a truly strange setup, since usually stars are way bigger than the planets traveling around them. What might explain this phenomenon is that the star we're talking about is not so much of a star anymore. It's a teeny white dwarf with a very tricky name. This dwarf is more of a stellar skeleton. It can't fuse elements within its core, which could prevent it from gravitational collapse. These days, it's a highly compressed, smoldering space body with an insane temperature of 49,500 degrees. In other words, the star is so hot that it's slowly vaporizing the nearby planet. Because of this insane heat, the planet is losing its atmosphere. The white-hot star is sending streams of vaporized material far away from the planet at a rate of about 260 million tons a day. Far-away Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. It's located 30 light-years away from Earth in the constellation of Leo. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. The distance between them is 15 times smaller than the distance between Mercury and the Sun. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, and it remains solid despite blistering temperatures. One of the most plausible explanations for this phenomenon is the incredibly strong gravity on the planet. It compresses the trace amounts of water vapor in the atmosphere into ice and then stops it from melting. Now, about 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is 5 times the size of Earth. It needs only 2 hours and 10 minutes to orbit its parent star, which is a pulsar rotating 10,000 times in a minute. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline, meaning that at least some part of the planet is diamond. Now, look at this hot Jupiter. That's the name used to describe planets orbiting their home stars uncomfortably close. On WASP 76b, it rains iron at night. As for the daytime side of this planet, the temperatures there rise up to 4,300 degrees. That's hot enough to vaporize metal. The bizarre planet is just a bit smaller than Jupiter. It's located 640 light-years away from our home planet. The terrifying weather conditions in this world are caused by its extreme orbit. WASP 76b is 10 times closer to its parent star than Mercury is to the Sun. It makes this star and the huge planet tidally locked. One of the sides of WASP 76b is always baking in the heat coming from the star, and eternal night reigns on the other side. Now, a mere 20 light-years away from the Sun, a bizarre rogue planet is roaming the Milky Way. This planet doesn't have a star of its own, but this nomadic world has an insanely powerful magnetic field. According to a 2018 study, it's 4 million times stronger than Earth's magnetic field. The exponent with a long and complicated name also produces amazing auroras. When SIMP was first discovered in 2016, astronomers thought they had spotted a brown dwarf. That's an object that's too large to be a planet and too small to be a star. But another study proved that the thing was small enough to be considered a planet. Of course, this planet is a mammoth among its peers. It's 1.2 times the radius of the largest planet of the solar system, Jupiter, and more than 12 times its mass. Astronomers say that the exceptionally powerful magnetic field helps the planet produce such stunning auroras, but they are generated in a different way than auroras on Earth. The scientists claim SIMP's moon might help the planet create its light shows. This planet is nothing like you've seen before. It's often referred to as a super Saturn or Saturn on steroids, all because J1407b has a huge system of rings. They're 640 times larger than those on Saturn. This exoplanet sits 434 light-years away from Earth. It's the only known world with rings similar to those on Saturn. If J1407b ever swapped places with Saturn, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. Gliese 581c is located 20 light-years away from Earth in the constellation of Libra. It orbits its home star at a distance that is a mere 7% of the 93 million miles that separate Earth from the Sun. Gliese 581c is tidally locked with its star. It means that one of its sides always faces the star, and the other is plunged into endless darkness. Of the sunny side, the temperatures are insanely high, and the dark side is freezing. But between these two extreme areas, there's a narrow zone with the conditions that could potentially support life. And how about visiting a planet where it might rain sapphires and rubies? Hat P7b is a pretty far away place. The planet sits more than 1,000 light-years away from Earth. On its night side, the atmosphere contains a lot of aluminum oxide, also called corundum, and corundum gems are sapphires and rubies. Astronomers think there might be powerful storms on the planet when it literally rains rubies and sapphires. That's why these gems might be scattered all over the planet. There's also a planet that eats up light. It's called WASP 12b. It's one of the darkest exoplanets we know about. That's because its day side consumes light rather than reflects it back into space. The planet is enormous, twice the size of Jupiter, and it traps more than 94% of the light falling into its atmosphere. This might be the reason for the insane temperatures there, 4,600 degrees Fahrenheit. WASP 12b travels so close to its parent star that it completes one orbit within a day. Its night side is twice as cool as the day side, a mere 2,200 degrees. But thanks to this difference in temperature, water vapor and clouds form above the surface of the planet, and then swirls of material from WASP 12b's superheated atmosphere spill onto its star. Now, see that jaw-dropping magenta-colored exoplanet? It's located in the constellation of Virgo. It's called Gliese 504b. The distance between this planet and its home star is 9 times the distance between the Sun and Jupiter. The planet is relatively newly formed. It's still glowing with heat. That's what makes its surface look pink. We've traveled 20,000 light-years and reached a red dwarf in the Sagittarius constellation. Far away from this cold star, there is a planet with another long and tricky name I'm not going to attempt. This world is so far away from its parent star that it receives very little heat. It's one of the coldest planets we know about. Its surface temperature is lower than minus 360 degrees. That's why the entire planet is encased in a thick layer of ice. If you stepped on its surface, you'd see nothing but glaciers, vast plains, canyons, and mountains of ice. And still, astronomers think life could exist deep beneath the chillingly cold frozen surface. The planet's core might generate enough heat to melt some of the inner ice. If it's true, then there can be an enormous subsurface ocean on the planet.